probably the most important section out of the statistics unit for testing, because they are going to ask about this more than most everything else. So this is measures of center. Actually, I didn't change the title here. Used to be measures of center outliers and spread. Okay, so there are two things that we are going to talk about today in this section, and that is how can we tell where the center of this data is, and how can we tell how spread out the data is. And there are some different values that we can use to describe that. So, measures of center, we have three that we are going to talk about. And you have probably talked about these many times before. The first is the mean, which is your average. To get that, you add all the values up and divide by the number of the values that you have. So you should be very familiar with doing that. The next is the median. Okay, median is the middle number. Put the numbers in order and find the middle number. And the last is the mode. Okay, the mode is the number that occurs most often in the data set. Mode is not as helpful most of the time, and some data sets don't even really have a mode because you don't have any repeated values. But there can be cases where the mode is important, because if a number is showing up a lot of times, then that gives you a piece of information that you may need to know. Okay, so mean, median, mode should be values you have heard about before. Going to be important for us to look at. All right, so how to find these values on Desmos. So just real quick, we already did a little bit of this, but if you have a data set, I'm not even going to put in a new data set. I'm just going to use the one I had right here. If you need to get the median, there are two ways that you can get median. Okay, you can just type median and whatever letter you're using, and it will give you the median. Or the 5-number summary does include the median. So that's another way to do it, particularly if you might need the quartiles as well. That might be helpful. Mean is super easy as well. Mean, parentheses, L, and it'll find the mean for you. So we're going to use Desmos a lot for this because it's just so much faster. Median and mean should be ones that you have found by hand a lot before. Desmos is super duper fast. And Desmos, you don't have to have your numbers in order. You can do it a lot easier. Desmos will not find the mode of the data, so you just have to look at your data points if you're looking for the mode of the data. Okay, questions? All right, so it's been a long time since I made this problem. You may see a familiar last name here. Huh? Is it got 2 T's? Yeah. Add a T. All right, so the prices of houses in a neighborhood are given. We want to know the mean price and the median price. So let's go to Desmos. Let's go over here. I'll call it H for houses, and I'm going to put in these house prices. Don't put commas when you're putting in this list, because if you put a comma, it thinks it's a new number. So 25,000, no commas. 150,000. All right, so we've got 6 houses in this particular neighborhood. And so it's very easy. Mean of H and median of H. So what do we see our mean and median prices are? Both of them are 150,000. Now, that does not always happen, obviously. You will not always see a median and a mean that are exactly the same, but in this particular case, they're the same. Now, in this particular neighborhood, you got all the houses ranging from like 100 to 200,000. They're pretty similar in their value, right? Some are a little more expensive, some are a little bit cheaper, but there's nobody that's like way above. But the Cockrams are going to build a house at the end of the street that costs $675,000. What does this do to the median and mean price of the homes in the neighborhood? Okay, so just make a prediction real quick. What's going to happen?
They're not going to get it.
Okay, they're going up, right?
That's not what they're looking for. They're looking for the big.
Huh?
They're looking for the big house. The really big.
Yeah. So this is going to go up. But what I want to do is consider how much this affects our values. So you can do this. You could just add the values there. I'm going to copy and paste, and I'm going to make this a new list. I'm just going to call it L. And I'm going to add that 625,000 to my list. Yeah, it is okay to just add 625,000. The reason I like to do it this way is because I can see my old values, and then I can see what's happened to my new values at the same time. So I just copied and pasted this list, and now I'm adding 625. So the great thing about Desmos is it does not matter because your numbers don't have to be in order. So will it do like a Control C?
Whenever I do Control C, it does, but I won't let me paste.
Control V doesn't work.
Oh, I didn't
Try Control V. It should work.
Isn't it 675?
Oh, sorry, 675, not 625. Okay, now when we look at this, what happened? Okay, our mean price increased by 75,000. What about the median? It stayed the same. Okay, so let's write that down. Mean increased by 75,000. Median stayed the same. And it stayed the same because you have two houses right here that are worth $150,000. They were your middle two. They were right there at the middle. So basically it switched from being maybe the Bobbitts to the Longworths, and their houses were equal amounts. Right? So which one would better describe the neighborhood overall here? Mean or median? Okay, median. Did I hear? Or mean? Which one do you think? Okay. If we use mean is $225,000. How many houses in the neighborhood are worth $225,000 or more? Just the one, right? Just the great big one at the end. Nobody in the whole neighborhood has a house worth $225,000 except for the Cockrams, right? So by using mean, it makes it look like the houses in the neighborhood are worth more than really any of the houses are worth, right? They're really not worth $225,000. Now, it might bring up property values a little bit if you got this really nice house at your neighborhood that, nice houses around each other, like raise property values a little bit, whereas if you have like a house that's a drug house somewhere in your neighborhood that's falling apart and looks awful, that you know, if that's your next door neighbor, it's going to be a little bit harder to sell your house. So that can lower property values. So maybe it does bring you up a little bit, but the median is a better measure here because really it's a neighborhood of $100,000 to $200,000 houses with one big giant house at the end that doesn't really fit in, right? Is what we've got going on here. So median would be a better measure for this because we've got this big outlier, right? That one big house that's a lot bigger than the rest of them. Let's see. Let's have, I'm going to split you guys down the middle. So right down here. If you're on this side, I want you to type in all of the math book pages over here. If you're on this side, I want you to type in all of the history book pages. Find the median and mean for both. Okay, so math over here, mean history over here. I'm going to try to type them both in. But. Yeah, do 3 places on decimal. Okay, so over here for my math people, what did you guys get for mean? 783.9, that's what I got. What did you guys get for median? 811. Okay, over here for my history people, what did you guys get for mean?
963.286.
I got the 963.286. There may be one number you got. 861. Okay, that's what I got as well. Yeah, so you, Lexi may have just have one number a little bit off. Okay, so these are our mean and our median. Let's talk about what's going to happen. All right, so our math was mean 783.9, and our median was 811. I want to know what's going to happen if there's a new book we add to the list with 1,200 pages. So if I go over here to my math data and I add one with 1,200 pages, my mean is going to change to 821.72 repeating. My median is going to be 828. So if we look at what happened right here, we went up almost 40. Not quite, but almost 40 pages, right? How much should we go up here? 17. Right? So both increased, but which one increased the most? The mean. Okay? Let's look at a similar situation with the history textbooks. So for history, our mean was 963.286, and our median was 861. Okay? So we want to know what if there's a new textbook with 435. Okay? So that's significantly lower than everything else that we've got so far. So if we add this 435 here, let's look at what happens to the history mean and median. This is going to go to 897.25, and this is going to drop to 841.5. Okay, again, we threw in a number that was a lot lower than everything else. This went down like 65-ish, 67, or 66, something like that. This did still go down, but just 19.5. Right? So whenever we add in outliers, numbers that are either really big or really small compared to the rest of our data, we see that the mean and the median may both change. There's some cases where maybe the median may not change, but our mean reacts more, right? So on the next slide, we're going to talk about outliers and their reaction to them. So the mean is more sensitive to outliers. So when we add that house at the end of the street that's $675,000, it shoots up the mean, where the median is more stable, right? Or if we add in a number that's super duper low, it pulls down the mean, but the median will be more stable. So the median is less sensitive to outliers. Okay, and this is going to be a key thing that we understand for answering a lot of the questions that we're going to see. Mean is going to be pulled up or down with outliers, whereas median may change, but it's going to stay more stable. Okay, so let's split this up as well, because if we don't, it'll take forever. So let's see. You3 right here, do set number 1 for me. Rosalind, Kaylee, and Isabella, you guys do set 2. Ian and Anna Grace, you guys do set 3. You two do set 4. Lanaya and Kama, you guys do set 5. Caitlin and Lexi, you guys do set 6. And Aiden and Giancarlo, you guys do set 7 for me. So find the mean and the median of both of these. All right. What do we got the mean for 7? $433. And then median, 333, okay? All right, any outliers? 45,000. So notice here, low outlier, lower mean. So what we're seeing is if we have an outlier, or especially if several outliers, it pulls that mean in that direction. But the median is more stable. It doesn't get pulled in that direction. So if the data has high outliers, the mean will be pulled up. If the data has low outliers, the mean will be pulled down. Okay? So let's think about this in terms of distribution. Okay? So in each situation, I want to know which one is going to be higher, the mean or the median, or there's an option of just saying they're probably about the same. Okay? So if I have this histogram here, and I look at it, let's practice some of our language we used yesterday. Is that normal, or is it skewed left or skewed right? Skewed right, which means it has high outliers. So the mean is going to be pulled up. Median is going to, mean is always pulled towards the tail, right? So the mean would be pulled towards the tail, so the mean would be higher on this. Median would be more stable. Okay? For the next one right here that says days between failure, I don't know. Probably like failure of like a machine part or something, but I guess it could be days between your just personal failures in your life. I'm not sure. I know, that'd be terrible. I don't know. I just copied and pasted this from a Google search, so I'm not sure what it meant, but interesting to think about what it might be. Which one is going to be higher, the mean or the median? I'm going to say mean because it kind of has a tail over here to the right side. The mean's going to be pulled up that direction. Okay? What about this next one right here? Mean or median? Which one's going to be higher? Median. Because the mean, you kind of have a tail to the left, the mean is going to be pulled down towards that tail. What about this one right here? Is it skewed?
I think it's skewed to the left a bit. It's normal distribution.
I mean, I can kind of see why someone would say that, but I think it's probably pretty normal. It's definitely not clearly skewed one way or the other. So if you have normal data, if it's perfectly like bell-shaped, then your mean and median should be about the same. So about the same. One might be a little higher than the other, but they should be pretty similar in that one. And what about the last one?
I think it's
Median will be higher on this one. Because mean is always pulled towards the tail. This one definitely has a tail over here on this left side. Okay? All right. Real quick, we're going to talk about measures of spread. All right. There's one that you should already know. It is range. And it is the highest value minus the lowest value. Okay? This is very sensitive to outliers because you are taking the outliers and subtracting them, right? You're taking highest and lowest. And your outliers are going to be your highest and lowest. So range is going to fluctuate a lot based on your outliers. The next one is called, probably one you haven't seen before, standard deviation. Okay, it's the way that it is figured is kind of complicated. I did used to have students actually figure up a standard deviation by hand, but we do not do that anymore. It just takes a little too much time. It is a measure that tells about the dispersion of values. So a high value would mean your values are really spread out. A small value would mean your values are really close together. Okay. Typically, you're going to discuss this in conjunction with mean. It is sensitive to outliers because it relies on the mean. However, not quite as sensitive as the range because the range is basically uses the outliers only. And then the least the most resistant to outliers is what we call the inner quartile range. And the interquartile range is basically the length of your box in a box plot. It is the middle 50%. So to find the interquartile range, you take the third quartile and subtract the first quartile. And usually this is going to be discussed with median. So, real quick, let's look at how you do these in Desmos so you at least have that. Okay? I'm going to enter this here. L equals 1, 2, 3, 4, 5, 5, 5, 6, 7. All right. So, if I want to find interquartile range, I would do stats L, and then I would just take Q3 minus Q1. So for this one, it would be 5.5 minus 2.5, and I would have an IQR, or interquartile range, of 3. Okay? Median, I don't know why I put that there for median. I don't know why that's here. Range is just going to be the maximum minus the minimum. I think I meant to put standard deviation there, and I didn't. That's what happened. Okay, we need to fix this because you don't know what. I don't know why I put median there. Standard. Fix this on your notes real quick. Deviation. You're going to type STDEV. And then L. I know it has STD in it. I didn't come up with this. Somebody who doesn't teach 9th graders came up with that abbreviation.
I didn't realize until you said it. I did.
I heard some giggles. All right. This looks longer than it is, but most of these are multiple choice. Okay. You may have a little bit of trouble with the ones dealing with spread because we didn't quite get to those. Take your best guess on those, and then we'll talk about them